Hello, welcome back. Today we are discussing this wormhole effect. We're going to create this using Three.js in a browser with JavaScript, just a points object, and we're going to populate the points using a cylinder geometry. Let's get started. I've got our basic Three.js scene here. I've added icosahedron in the middle of it to create a nice ball with a normal material. Let's change that to a cylinder geometry. Did I spell that right? I don't know. Let's try it again. Cylinder geometry. Good. And let's see what it needs. I think it needs radius top, which we've already defined for the radius of our ball. Radius bottom, same. Height. Let's call that length. Tube length, because we're going to probably use that somewhere else. Who am I kidding? We're definitely going to use it somewhere else. Okay. What else do we need? The radial segments. Let's give that a 32. And the height segments, 1024. Or something smaller. How about 256? And do we need anything else? Open-ended? Yeah, true. It is open-ended. And that's all. It's no longer a ball, it's a tube. And it's rotating on the y-axis, you can't really tell. In fact, it's difficult to tell that it's rotating at all. So anyway, this is a good starting point. Let's say rotate X, now you can actually tell that it's rotating. This is a good starting point. This piece of geometry, this cylinder geometry, has the points that we're going to use in our points. So instead of adding that to the scene, we're going to use it to populate a points object. Let's call that const points equals new 3 dot points. Not point cloud, just points. And it takes a geometry, which will be geo, and a material, and that'll be points, or just mat, because that's all we need. And then scene.add points. It's gonna look very bad right now because we're using a mesh normal material. In fact, let's look at that. Let's look at that output in the console. Is it mad? Not. Oh, it's very mad. Tube is not defined. Points. Okay. So, I don't know if you can even see that. The material is the wrong type of material. Let's give it a points material. And that's going to take an object with a size property, and we'll give that a 1, because we don't know any better, and a color property, which we'll give, how about blue? X0099FF, kind of a light blue. Okay, so 1 looks a little bit big. By the way, seeing a little bit of depth hue in here, it's very subtle, and that's because I have fog in the scene. If I jack that up some more, it'll be even more pronounced. That's like a little free depth hue. I think that's pretty cool looking. Anyway, not what we're going for. We're going to reduce the point size a little bit. I don't know, to a quarter that big. Cool. And also dial back the depth a little bit. Doesn't need to be so intense. Cool. Because we'll use that more later. Some things that we need to do is stop rotating on the x-axis. Instead, rotate it on the z-axis. Okay, and also, oh, maybe that's not right, but let's see. Points dot rotation dot y equals math math.pi times 0.5. Math.pi times 0.5, let's do rotate x, is the same as 90 degrees. That looks weird. That's not what I'm expecting at all. Comment that out for a second, see if that point's rotation is correct. Nope. Yep, that's right. And now if I rotate y, it should spin like that. Good. We still need to kind of move the position of the points around a little bit. Move it toward the camera and color it. Let's start with moving the position of the points around a little bit. We can modify the geo. So let's say const, call it tube verts is equal to this geo.attributes.position. Okay, and we're going to, let's see, we're going to need a couple of vector 3s. We're going to iterate through every one of those vertices, and we're going to move it around using noise. We've already included our noise library, our noise module. So we'll need two vectors to do this. What we're going to do is kind of copy the position of the vertex into a vector, create some noise, and then add that noise to the vector, and then set the position again in the array. It looks like this. Let p equal new 3.vector3, and we can just duplicate that line, but give it v3. Good. We've got a couple of vectors. We need noise, so const noise equals new improved noise. Yay, noise. And now let's iterate over those vertices. Let I equal 0 and len equal tube verts dot length, while I is less than len, I plus equals 1. Good. There's our for loop. We're going to, I can't remember how to do this, so I'm gonna have to cheat and look at the old file, but we're gonna copy that position. I think it's p dot from buffer attribute, two verts, or not one, but I think that's right. Did it give us a clue? Attribute and then index. Good. That looks correct. So we've copied from that buffer array attribute a vertex 3 based on that index. All right, let's not dwell on that too much. Let's also copy that into our other what am I trying to say? Vector 3. Okay, and now we'll create the noise. We'll call this vertex noise. Yeah, equal nothing. It's going to be an integer, or rather a floating point number. So vertex noise equals noise dot noise. This is where the magic happens, and we need to pass an x, y, and a z. Let's give it v3 dot x, and we're going to multiply that by some sort of noise freak. I'll explain this in a second. Doom, and we want a z and a y. And by the way, I don't really need that to be up there, but instead I'll put this noise freak, the frequency of the noise. For now, we'll leave it at 1. Now I'm going to take that vector 3 that I copied, and I'm going to multiply it by this noise, each one of those adders. So it looks like this. v3 dot add scaled vector, I think it is. So I'm not multiplying, I'm adding. And the vector is v3, no, p. And then the scaled vector is the vertex noise. I think that's right. Now I'm going to, let's see, how do you do this again? I'm going to set the XYZ. So tube verts dot set XYZ, and I need an index I and XYZ. v3.x, v3.y, and v3.z. Make that a dot. And save. Oh, look at that. I'm going to add my orbit controls, which I have saved as I forgot what you call it. Inside of VS Code, you can have little snippets of code, and then let's see, orbit init, and it saves you some typing. So now I can kind of look around. Isn't that nice? I kind of don't want the Y to be noisy. In fact, let's make these a little bit smaller so you can see. Like so. Now the points will be a little bit smaller. See how the Y, I don't want that. I don't want the points to be moving around the Y axis. So I'm just gonna set this to their initial value. So now the Y is consistent, but the Z and the X are all noisy. Noise frequency is intense. If I scale that down, you'll see it's like they're just kind of, it's like wavier and less chaotic. Also, let's make this longer, like 100. Now I have a really long tube, and the points are too far spaced out now, so I'm gonna scale that up as well, 2048. So now we get these nice lines. Look at those. Isn't that beautiful? Good. I've gone through the vertices and added noise to each of them. By the way, you can scale that noise times noise amplitude. Let noise amp equal 0.5. So let's scale it down by half and see what effect that has. So it's wavy, but the waves are smaller. In fact, let's increase the noise frequency. So there's more waves, but they're smaller than if I had this set to 1. See, now the waves are wavier. If I set it to 3, it's like they're so wavy, which is a really cool effect. Okay, so let's scale that down. I like 0.5. I think the noise frequency can stay at 5 for now. We got to do 2 more things: the color. How are we doing on time? The color and animating the tubes toward. Let's start with moving the tubes toward the camera. Actually, no. Let's start with the color because that's more fun. Let's create an empty array to hold the color, and also let's slow that down a little bit. It feels a little bit fast. Now it's rotating a little bit slower, less frenetic. Const colors is equal to an empty array. Colors. Let's create another let's duplicate this noise freak and call it hue noise freak. So we're going to use this for the color. Oh, and let's create a new color too. Let's call this const col equals new 3 dot color. Okay. Do we need to create a new? So we've got our vertex noise. We need our hue noise as well. I'll need this to be up here. It'll be down here. Noise dot noise, and we'll pass in these same guys. I like them, except we'll use the hue frequency instead. The hue noise freak, and we're gonna set that to something smaller. I think like 1/10 as big, and then we'll take our color and dot set HSL, hue, saturation, and lightness. And our hue we want to be, let's just take the Y value. You could take any of those. It's just a noise value. Actually, sorry, I did that wrong. Hue noise. The saturation will be 1, the brightness will be 0.5, or the lightness rather. And now we're going to push that into our colors array. We want the col.r, the col.g, and the col.b. Okay. One last thing, we need to set the attribute on the geometry for that. I think it's geo dot set attribute. No, that's not it. Set attribute. The name of the attribute is color. It's a new 3.float32 buffer attribute. Colors. And there's three elements in each attribute, R, G, and B. I save that, and we will see nothing, no change, because the material we're using for the geometry doesn't know we're using vertex colors. Let's tell it that we're doing that. Where is it? It's here. Here's the material. Get rid of the color attribute and say vertex colors is true. We need a comma behind size and vertex colors like that. Does that work? Oh, look at that. Isn't that nice? The hue is being set based on the position. Let's see. I wonder if I can modify that. Let's scale it down a little bit. The hue noise frequency will be 1, so it should be, the color changes less frequently. That's a little bit low. There we go. Isn't that nice? The last thing we want to do is move this toward the camera. We could just update the position on the Z position plus equals, I don't know, 0.2. Let's see what happens. So now it kind of moves towards us. We're out of time, but play with the hue setting, the hue. You could set you could play around with the values that you're passing into the noise function here to get a different hue variation. Also, once the points reach a certain position, reset them like this. If the points dot position dot z is greater than some value, I don't know, 5, then reset it. Points dot position dot z equals a negative 20. Whatever the value is, figure out what that is, and also let's speed it up and see if we can see that, what effect that has. So see how it's popping back? If it's greater than 5, let's say if it's greater than, I don't know, 25. Greater than 50. It's probably greater than the tube length. What is the tube length? 100? It is. Negative 40. Let's try that. There you go. A good idea to try is to create 2 tubes and put them right next to each other so that you have this continuous experience, kind of like this. Hang on, what did I do with the hue here? Because I really like how that turned out. The color noise. Oh, look at this. Look what I'm doing for Z. I'm taking this small value. I think that's cool. And let's see what effect that has. Instead of just using the Z position, I'll use the index. And let's see how that looks. I'm not sure I see a big difference. I'm going to scale that down even more to 0.1. I'm also animating the camera around using a sine function here. Sorry to cut it short, but we're out of time. Here's that camera animation. Let me know what you think. Leave a comment. Also, if you have any questions or if you have an idea or a question, something you'd like to see, leave a comment below. Thank you so much. See you next time.